As we've discussed before, there are several different methods for solving quadratic equations. In this video, we're going to learn how to use the quadratic formula to find the solutions to, or the zeros, of a quadratic function. So, let's first review the standard form of a quadratic equation, which is ax squared plus bx plus c equals 0, where a is the coefficient of x squared, b is the coefficient of x, and c is a constant, or just a number. Now the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It may look complex, but I assure you it makes complete sense, and you'll learn where this comes from in later lessons. But for now, let's just trust that it'll get you the right answer. So let's walk you through some examples. Here's an equation, 0 equals 2x squared plus 10x plus 12. How could we use the quadratic formula to help find the solutions to this equation? Well, step 1 is to write the equation in standard form. You may notice that this equation is already in standard form, so there's nothing to do here. Step 2 is to identify the values of a, b, and c. Well, a is the coefficient of x squared, so that's going to be 2. B is going to be the coefficient of x, and that's 10. And c is the constant, 12. Step 3 is to rewrite the quadratic formula using parentheses and to substitute the values of a, b, and c into it. So I'm going to rewrite the quadratic formula, replacing all of the variables with parentheses, and then I'm going to substitute the appropriate values. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times the value of a times the value of c all over 2 times the value of a. Now the last step, step 4, is to simplify that expression and evaluate to determine the two solutions. And when you simplify that whole thing, what you get is x equals negative 5 plus or minus 1 all divided by 2. And remember what plus or minus means. It means we first have to add 1 to negative 5 and then divide by 2. And then we have to subtract 1 from negative 5 and divide by 2. And when you do that, you get x equals negative 2 or x equals negative 3. So there are two solutions to this quadratic equation. And for most quadratic equations, there's going to be two solutions. In fact, try plugging in negative 2 and negative 3 into the original equation, and you'll find that the right side evaluates to 0 in both cases. Now, you may be a little intimidated or confused about how I went from step 3 to step 4, so I'm going to break that down for you. I'm going to take step 3, that big equation, and I'm going to show you how I simplified the right side. Step 1 is to simplify the expression underneath the radical sign. So we're going to isolate 10 squared minus 4 times 2 times 12. Now if you plug that into your calculator exactly as you see it, it'll give you a 4. So you can simplify that expression to be negative 10 plus or minus the square root of 4 over 2 times 2. Step 2 is to simplify the radical and all the other terms. Well, negative 10 is just negative 10, the square root of 4 is just 2, and 2 times 2 is 4. Step 3 is to simplify the fraction. Now if you notice, we've got three terms in this fraction, negative 10, 2, and 4, all of which have factors that are divisible by 2. Or I should say all of which have a factor, or all of which have a common factor of 2. So if we divide everything by 2, we get x equals negative 5 plus or minus 1, all divided by 2. And step 4 is to evaluate that expression, if necessary. Now, there are two ways of expressing these answers. All right, you could express it using set notation or just a decimal approximation, or a decimal if you don't need to approximate, if we're working with real numbers. So when we do this, we get x equals negative 2 or x equals negative 3, and expressed as a set, we put negative 2 and negative 3 in brackets. It's important to note that this is not an ordered pair. If it were, I'd put it in parentheses, but because I've put it in brackets, I'm expressing a set of solutions, or this equation's solution set. Let's walk through another example. Here's another equation. Negative 10 equals 2x squared minus 7x minus 13. So step 1 is to write the equation in standard form. you may notice that this equation is not equal to 0. So we need to set one side equal to 0, and it should be easy to see that the easiest way to accomplish this is to set the left side equal to 0. So I'm going to add 10 to both sides, giving me 0 equals 2x squared minus 7x minus 3. Step 2 is to identify the values of a, b, and c. The values of a, b, and c are 2, -7, and -3. Step 3 is to substitute these values into the quadratic formula using parentheses. So I'm going to rewrite the quadratic formula, replacing the variables with parentheses, and substitute the appropriate values. X equals negative b, which is -7, plus or minus the square root of b, -7 again, minus 4 times a times c, all over 2 times the value of a. And finally, step 4 is to simplify the expression and evaluate to determine the two solutions. So x is going to equal 7 plus or minus the square root of 73 all over 4. Now, because the square root of 73 is an irrational number, there's no way to write down the precise values. So sometimes it's appropriate to write down decimal approximations. So we could say that x is approximately 3.89, or x is approximately negative 0.39. Now, again, don't worry about going from step 3 to step 4. I'm going to break that down for you. So let's take the equation in step 3, and we're going to simplify the expression on the right side. Now, step 1, simplify the expression underneath the radical sign. Let's isolate that and just work on that first. Now again, if you plug this in exactly as you see it into your calculator, parentheses and all, it will give you the right answer. So what's -7 squared minus 4 times 2 times -3? Well, that should give you 73. So we've simplified the expression underneath the radical sign. Step 2 is to simplify the radical and other terms. Now, the square root of 73 cannot be simplified, but -7 is the same as +7, and 2 times 2 is 4, so we could rewrite this as +7 plus or minus the square root of 73 all over 4. Step 3 is to simplify the fraction, and we notice that although we have 3 terms, these terms do not share a common factor, so there's really nothing to do here. We can't simplify that fraction. And then finally, step 4 is to evaluate if necessary. So there's 2 ways to express this answer. We could express it as a solution set, which would be 7 plus the square root of 73 all over 4, and 7 minus the square root of 73 all over 4, or we could express it as decimal approximations. X is approximately 3.89, or x is approximately negative 0.39. Let's try one more. So here we have the equation negative x squared equals 8x squared plus 4x minus 16. Step 1, write the equation in standard form. Now, is this equation equal to 0? No, so it's not in standard form. Let's set it equal to 0 by adding x squared to both sides. This gives us 0 equals 9x squared plus 4x minus 16. Step 2, identify the values of a, b, and c, and our values are 9, 4, and -16. Step 3, substitute these values into the quadratic formula. So we first rewrite the quadratic formula, replacing the variables with parentheses, and then inserting the appropriate variables in the appropriate places. So x equals negative b plus or minus the square root of b squared minus 4 times the value of a times the value of c all over 2 times the value of a. And finally, step 4, simplify and evaluate. And this gives us x equals -2 plus or minus 2 times the square root of 37 all over 9, or the decimal approximations 1.13 or -1.57. So let's take step 3 and break it down. How do we simplify this expression? Step 1, simplify the expression underneath the radical sign. What is 4 squared minus 4 times 9 times -16? Well, that gives us 592. Step 2 is to simplify that radical and the other terms. Well, the square root of 592 can be simplified as 4 times the square root of 37. The -4 is just -4, and 2 times 9 is 18. Step 3 is to simplify this fraction. And if you notice, negative 4 times the square root of 37, and 18 all share a common factor, 2. So we can divide all those terms by 2, which gives us negative 2 plus or minus 2 times the square root of 37 over 9. And then finally, we evaluate if necessary. So we could express this as a solution set, negative 2 plus 2 times the square root of 37 all over 9, or negative 2 minus 2 times the square root of 37 all over 9. Or we could use decimal approximations. X equals 1.13, or x is approximately negative 1.57.